You want to build an AI agent, yet every solution out there is trying to sell you on a platform as a service, but all of your data, identity, business logic, it all runs on AWS. So shouldn't your agent also run on AWS? In this video, I'll show you step by step how to build and self-host an agent on AWS Fargate using Mastra and the Serverless Container Framework. So on that note, let's dig in. All right, so for this project, we're going to be using Mastra, a TypeScript AI agent framework from the creators of Gatsby. So let's have a look at what it looks like in practice. First, we have the agents defined in code, which includes the prompt, model definition, and memory, which is used for conversation history, semantic recall, and working memory. We also have the tools, which the agent will call automatically when using the LLM. And we have the built-in server, which provides us the observability so we can see the traces, has an API server for the tools and agents so we can access them programmatically, and a dashboard so we can easily interact with all of our tools and workflows. There are loads of other great features like MCP support, workflows, retrieval augmented generation, so I definitely recommend exploring those on your own. Now let's have a look at the Serverless Container Framework, which supports deployments to both Fargate and Lambda, which we are going to be using for the Fargate deployments. Not only can you deploy to Lambda and Fargate, you can also migrate from Lambda to Fargate with zero downtime simply by updating the configuration and redeploying. When you deploy with the Serverless Container Framework, it provisions everything you need, including CloudFormation distribution, Fargate, LLB, and all the integrations. And lastly, we have dev mode, which enables fast iteration with hot reloading and local emulation. With the Serverless Container Framework, we had a choice between deploying to Lambda a serverless environment or Fargate a container environment. And in this case, we chose Fargate for a few reasons. With Lambda, we pay for the invocation, but when using LLMs, most of the invocation time is spent waiting for the LLM response. This is further compounded when we use an agent, as it may make multiple LLM and tool calls in a sequence. If we use MCP servers with standard I/O transport, it will increase cold start times due to the MCP server startup times. Lastly, server-side events, SSE, is the most common pattern for LLM responses, but that is not supported by the API gateway. As an alternative, you can use Lambda function URLs, but those do not support custom domain names. Now we know a little bit about Mastra, the Serverless Container Framework, and why we're going to be deploying it to Fargate. So now let's dive into some code. Before we get started, we're going to need an AWS account, Docker set up locally, probably using Docker Desktop, the Serverless Framework account, which you can get at app.serverless.com. We will need a Postgres database. In this case, I'm going to be using neon.tech as a serverless database. You're going to need an OpenAI API key, which you can get from platform.openai.com, and you're also going to need a Slack account. So the Slack part we're going to be setting up in the process, but you do need to have Slack already set up. All right, so first, if you don't already have a serverless installed, you'll want to run this command. I don't need to run that. I have serverless installed, and I also have an alias for the letter S as a shorthand for serverless. You'll need to log in. And in my case, I am using AWS SSO for authentication with AWS, in which case I have to run this command, but you'll have to set up whatever credentials you use. All right, now I believe we have everything set up, so we can now create our very first project. We're going to get started with the npm create command, and we're going to use Mastra at latest. So we're going to start with a brand new Mastra app. We're going to call it the Mastra Slack agent. I'm going to create the project. Have to wait a moment for this to set up. In this case, we are going to save this in the SRC file. We are going to set up a new agent. We're going to skip the workflows. We're not going to be using that yet. We'll add a tool just because it's easy to start with that, and we are going to be using OpenAI. We're going to skip that API key because we're going to create a .env file. And sure, let's add the example. All right, now that's done. So I open this up. All right, we have this project set up. So we're going to get started. I'm going to move the env file to env. All right, we will need to set up the open API key and the Slack app name. You should set your API key here. I'm going to put mine in. Now I've created the serverless containers YAML file. This is used by the Serverless Container Framework to instruct the framework how to deploy this agent. Now that we have the serverless containers YAML, we have to specify some properties. First one is the name. We're just going to call it the Serverless Container Framework Mastra agent. Need to give it the deployment configuration. In this case, we're using type AWS at 1.0. This is currently the only supported deployment target for the Serverless Container Framework. Now we are going to be defining our containers. So under containers, we specified agent. In this case, agent is the key that we're going to be using. It's the name of this container. We have to specify the source. And we also define the compute. In this case, we are using AWS Fargate ECS. Alternatively, we could be using Lambda, but in this case, we are deploying to Fargate, and therefore we also have to specify the CPU and memory. Next, we define the routing. In this case, we define the path pattern, which is how we're going to be mapping the API requests. And we also specify the health check. In this case, you could use something like, /health. We don't have that defined, so we're just going to be using the root. With the environment, we specify which environment variables to set. In this case, we have the open API key, and we use this variable reference to get the open API key, OpenAI API key from the .env file. And we also set the port so we can reference that. And lastly, we specify the integrations. In this case, we are creating a new integration, giving it the name Slack, and we are specifying the type to Slack. We also have to pass in the name, which we get from the environment variable Slack app name, which we set in the .env file. This integration is what the Serverless Container Framework will use for configuring Slack. Now that we have the serverless containers .yaml file set up, we can run serverless init, and this will be used to set up the Slack integration. I'm going to copy this value. So in another window, I opened up that URL and generated a new configuration token, and I copied the access token and I pasted it in here. And I also need to capture the refresh token. Serverless Container Framework now open up Slack, and it is asking for me to authorize it in a browser window, which I will allow. And next, we have to go to this URL. It opens up automatically in the browser, and under there's a generate token and scope. So I click on that. I follow these instructions, and I paste the value in here. So everything is now configured. If you go to Slack now, you will see that a new app was created. Everything was pre-configured for you. And now what we need to do is we need to capture these environment variables. We're going to copy and paste them, and we can place them into our env file. All right, so now that we have the Slack app installed, we're going to set up the Postgres database as the storage for Mastra. So the first thing we got to do is add a environment variable with our database connection string, and we'll save that. All right, so next we're going to set up Postgres for the memory storage, but first we have to install the dependencies. Next, we're going to replace libsql with Postgres store. However, we want to create a single instance of the Postgres store, so we're going to create a new file. And in here, we're going to define our store. And this is going to be our store configuration. As you can see here, we are using the DB URL connection string. And then we're going to use this storage in both Mastra and the agent object. And we'll do the same for the agent. With the Slack and DB connection environment variables set in the .env file, we also have to make sure that they are made available in the container. So in the serverless.containers.yaml file, we have to set the environment variables in the environment property. Before we can run this in a container, we have to set the server property. So now we can run dev mode. All right, so the server is up and running. We can open it up in a browser. Great, so dev mode is running and Mastra is running in dev mode, and we have access to this dashboard which gives us the agents and tools, and we can interact with everything here. So let's test this out with a simple prompt. Great, so everything is working. Mastra is running in dev mode locally. It is connected to Postgres with the memory storage, and we are able to chat with it using the LLM connection with OpenAI. Everything looks good locally, so let's deploy this to Fargate. Looks like the deployment completed, and now we have a URL to our Mastra server. Great, so we just opened up the URL, and looks like our Mastra server is up and running in prod. We built an agent using Mastra, ran it locally with dev mode, deployed it to Fargate using the container framework, but right now the only way to interact with it is with the API or using the Mastra dashboard. So let's add some integration so we can interact with it by other means. At the very beginning of the video, I promised that we'd be able to talk to our agent from Slack. So to do that, we have to create a Slack app and connect it to the Slack API. And there are two ways of connecting. One is socket mode, in which our app makes an outbound connection to Slack, which is great for local development because we don't have to traverse the network from Slack to our app. The other is HTTP mode, which is used for production, where Slack can reach our app via HTTP. We're going to get started by using the socket mode first, and then we're going to add support for the HTTP connection later. So to do that, we're going to need a few things. We're going to need to install the Bolt API. And we're going to include two things here. First, we're going to import the Bolt library. And we're going to import this type, agent generate options, which we're going to use for the configuration. First, we're going to create a variable called socket mode, which we're going to use later to pick between the socket mode and HTTP mode. And here we are checking the serverless local environment variable, which is provided by the Serverless Container Framework, and lets us know whether we're running the app in dev mode or if it's released to prod. Here we're defining the configuration that we're going to use for Slack, and this requires a few parameters here. So we've defined this configuration. The token, signing secret, and app token are all coming from the .env file, which we defined previously. And if you remember correctly, those values came from the init command that we used to set up the Slack app in the first place. The fourth parameter here, socket mode, this is just a Boolean based on the environment variable that we set before. And so this is how we let the Bolt app know that we're going to be running this in socket mode or HTTP mode, because that Bolt app can only run in one mode at a time. So next we can initialize the Bolt app. We've added the Slack app, but there is no message handler yet. So we're going to create a new event handler stub and connect it to the Bolt app. We have this stub for the event handler. Now let's define the inputs. All right, so we have the inputs here. We have the event, context, and say. Event and context provide us some of the context that we need to process the message. And then we have the say, which is a function we can call, which will send a response to Slack. This event handler gets called on all messages from Slack, but we only want to respond to DMs and mentions in channels. As such, we need to add some logic for this. Right, so we've added a few things here. The first one, we added a variable is DM, and we recognize this when the event channel type is set to IM. This is when Slack is sending that DM. The second is mention, and to process that, we create a new variable text message, which is the incoming text value. Though we had to cast this a little bit in TypeScript to get that variable out. And is mention, therefore, checks for a string of a specific format. And this format is what Slack uses to identify users. So when you @ somebody in Slack, it uses this format in that incoming .text value. And in this case, we're identifying the bot user ID. This is the user ID of the bot that we are running, meaning this agent. So we're basically looking for whenever the bot is mentioned, and this can be in a, this could be in a DM, it could be in a thread, anywhere. Then we have should respond, which just checks if this is a DM or a mention, and this is when we're going to add the response logic. Right, so now we can start adding some logic for processing the message, calling the agent, and then responding. We're going to need to set a few things here first. All right, so the first thing I'm going to do here is I'm going to get the response thread ID. So I'm going to create a new variable. Right, so I've extracted this thread TS property. TS stands for timestamp. The event has two properties. There's the thread TS and then just .ts. If there is an existing thread, then the thread TS property is set on the incoming event. But if it isn't set, then we're going to use the event.ts and set that as the thread response. If there's a message, incoming message, and this is in a channel, what we're doing here is setting that thread ID if it isn't set, and therefore the response will be in a new thread in Slack. Which is why we're setting this thread ID in both of these cases. We're going to use this response ID in two different ways. One is it's going to be used for setting the response to Slack, but we're also going to use it in Mastra. So Mastra, as mentioned before, has memory. And in order to persist that memory, we need to associate it with a resource ID and a thread ID. And so we're going to use the thread, or we're going to use this response thread ID as a thread ID in Mastra for persisting the memory. So for that, we're going to create a new variable. So we've specified this agent options, which is a agent generate options. This is specifically for Mastra with two properties, resource ID and thread ID. The thread ID is this response thread ID, and then the resource ID is the bot user ID or bot ID, or just quote unquote bot. This is resource ID in Mastra typically represents a user. So a single user might have a thread ID. However, in this case, the user is the agent, which is why we're using this bot user ID with some fallback. So next we need to call the agent and send that response. So let's create a placeholder here. And we're going to send the response. Okay, so we've set this response message and we use the say method. So this would just send a blank message to that thread. And here is where we're going to add the logic. So first thing I added here is a error handler. So there's an error calling the agent. We'll respond a kind of more friendly message with some error information in Slack. Now let's implement the call to the agent. Okay, so first you'll notice that I created a variable called generate options, which is a copy of the agent options, but then defines this output as undefined. This is really just a workaround, honestly, because there's a quirk in this call with generate options that requires, I believe it's in TypeScript, it requires output even though it can be set to undefined, otherwise it throws an error. So then we specify the text message, which we send to the Mastra agent, which is this weather agent. Text message, and this is the variable that we defined previously with a text content. Lastly, we set the response message to the text response that we get from the generate call. Now that we implemented the Slack app and the message handler, now we need to do one more thing before this will work properly. This will start the Bolt app and start the server. We only need to do this in socket mode because in HTTP mode, the Mastra server will handle the incoming requests. Let's test this out now with Slack. Okay, so now in Slack we can ask about the weather. And as you can see, it started a new thread. We can open up the thread and we see the message in here. Let's also try this. And here we see the error message that we had in our error handler for a location that could not be found. This is looking really good for development, but it's not really designed for prod use, because in prod, we're going to want Slack to make the API request via HTTP to our service as opposed to running it in socket mode. So let's implement the HTTP support now. We'll need to import a couple methods and types. Here we've imported the context type from Hono and register API route from Mastra. The context is imported from Hono. We do not need to add that as an NPM package because it's already installed with Mastra. Now we'll create a stub method for the request handler. And we'll create a variable API routes, which we will use to pass to Mastra. We've created this API routes variable, which if it is in socket mode, will just be an empty array. Otherwise, we register the API route for the Slack handler. And we have to add this to the server property in Mastra. Before we implement the request handler, we're going to implement a method called verify Slack signature, which is going to be used for verifying the Slack requests. And if you haven't already, I just remembered that we have to add the crypto library. We have verify Slack signature implemented here, which takes the incoming headers and verifies the signature. This is a way of ensuring that the requests are in fact coming from Slack. And we do this using that signing secret we saved in our environment variables. So now we can start implementing the request handler. So we've implemented the call to verify Slack signature, and that returns immediately if the signature is invalid. When you are first configuring your URL in Slack for the app, it will make an API request to this endpoint with this body.type set to URL verification, and we must return the challenge. This is how Slack ensures that the API responds as expected. Now we can start adding the logic for the event handler itself. So in this section, we're handling the event callback type from the Slack API. And you'll notice that we set the response to just a status OK JSON response, and then we call the bolt app.process event. The process event is what's going to be processing the incoming event from Slack in the Bolt app, and then we just return that response. The important thing to note here is that process event is being called async, meaning we are not awaiting for a response before we continue. This is because the Slack API expects a response within a certain time frame, a short time frame, much longer than it takes to process the request with the LLM response. As such, we return immediately, but allow the process event to be called async. Now we need to define the event payload that we pass to the Bolt app. Here we define the event payload that we pass to the Bolt app, which defines the body and the ACK. The ACK is a function that the Slack Bolt app will use to acknowledge this incoming request. So we still have to implement this ACK function. Mastra uses Hono, which does not send the API responses until the method is returned. As such, the ACK function only sets the ACK response variable as opposed to sending the response. So now we have to return that ACK response. So we have Mastra, it's ready to go. We set the API routes, we register the API route using that request handler. So all we have to do now is deploy. Not only did the Serverless Container Framework deploy the app, it also got the URL from Fargate and then updated the Slack app configuration with that URL and disabled socket mode. So the app is now ready to use in production using the API, not socket mode. All right, we did it. We built a self-hosted agent using Mastra and deployed it to AWS Fargate using the Serverless Container Framework. Now, before we go, there are definitely a few things I recommend doing next. The first thing is updating your code for the agent and tools. In the examples, we're using what's available out of the box with Mastra, which is just this weather app. Definitely not a real world use case. You're going to want to replace the tools with real API calls to your internal services, and of course, updating the prompts on the agents. You'll also want to check out some of the serverless container features and other integrations like the AWS Event Bridge, as well as the scheduled tasks, so you can do other async type of work that is triggered by other types of events. And lastly, check out some of the other Mastra features that I had mentioned before. All right, yeah, thank you so much, and hopefully this was helpful. And if you have any questions, definitely reach out to us.